In previous lessons, we've demonstrated that if we have a Cartesian plane like this, and then we have a curve, which is, say, y equal f of x, if we want to measure the area between the x-coordinate a and b, this area here, what we need to do is this area is we need to calculate the integral between a and b of f of x dx. Now, this is valid because here f of x is above the x-axis. Okay, so now we are just going to imagine something a bit different. First, at the moment we are in the 2D plane, but if we had a third dimension, and so now we are in 3D, and we are going to rotate this thing around the x-axis. And so that's going to basically be something like this, and this, like this. And that's going to make a solid, which is called a solid of revolution, because we have turned 360 degrees. Right. So, okay, so it looks like this. Okay, so what is the volume of this solid? Well, what we can imagine, we're just going to cut like little slices in this volume. So here that's basically kind of like a bit like a coin. And what is the volume of this little coin? The volume of this little coin is, well, it's the volume of the disk, which is pi times, so the thickness of the coin here, it's called dx, little x. So it's pi times, well, here it's f of x. So it's time pi f of x square, because you know the volume, the area of a disk is pi r square. And then to give it a volume, we time by dx. And if we were going to calculate, add all of these little coins, so there is a little coin here, and then there is another one here. Okay, so we need to add all of these little coins and the total volume. So I'm just going to say this is the small volume, and the total volume would be the sum going from A to B of these little volumes, so which is pi times f of x square times dx. Yes. That's how we're going to calculate volumes of revolutions. Okay, let's do an example. Say, for example, we have a cone, so basically a line like this. And we are going to rotate it around the x-axis. So what is the equation of this line? Let's call it y equal to x. It's not really up to, doesn't really look like y equal to x, but it doesn't matter. And we are going to integrate between x equals 0 and x equals, say, 3. So the volume of the space that would be created, I'm sure that you would agree with me, it's a cone. So the volume of a cone would be, so the integral between 0 and 3 of pi times, I'm using the formula before, f of x square times dx. Right, so that's, let's substitute by f of x equal to x now. So that's 0 to 3 pi times 2x squared dx. So the v is 0 to 3 of pi, that's what, 4 pi x squared dx. So v is equal to, we can pull out the 4 pi, 0 to 3 of x squared dx. And so that's v is equal to 4 pi times x3 over 3, which is a primitive of x squared, 0 to 3. So that's 4 pi on 3 of x cubed between 0 and 3. So it's equal to 4 pi on 3, 3 cube minus 0 cube. And so it's equal to, yes, what, 4 pi times 27 over 3, which can be simplified. Yes. Now, another example is using this, we can calculate the volume of a sphere. Now, okay. So, okay, for a long time you have been told that the volume of a sphere is 4/3 by r square, by r cube. Well, we're going to demonstrate that now. It has taken that long. Right, so let's imagine a half circle, and the radius of this half circle is r. So basically we are moving between minus r and r. Here is 0. What is the equation of this? The equation of this is y equal root of r square minus x square, because the equation of the circle is y square plus x square is equal to r square when it's centered on O. So I'm only considering the part above the x-axis. Now, right. Now, if I rotate that around the x-axis, obviously that's going to make a sphere. So, let's calculate the volume of this sphere. So v equal, so x vary between minus r and r, and it's pi times, so f of x squared dx. But, okay, so therefore v equal minus r to r of pi root of r square minus x square dx. So that means that v equal, we can pull out the pi, minus r to r of r square minus x square dx. Right. So it's pi, and we can integrate that. So what is that? R square x minus x cubed on 3 between minus r and r. So it's pi times, so it's r cubed minus r cubed on 3 minus, so what is this? Minus r cubed plus, oh, you know what? Let's go slow. Don't want to make a mistake now. Minus r cubed on 3. Right, so it's v equal pi times r cubed minus r cubed on 3, that's 2r cubed on 3, minus, and then the other bit is what? So minus r cubed, that's plus r cubed on 3. So it's pi times 2r cubed on 3 minus 2r cubed on 3, which is equal to pi times 2r cubed on 3 plus 2r cubed on 3. So therefore V is equal to pi times 4r cubed on 3, which is generally rearranged as 4/3 pi r cubed, and which is the volume of a sphere that you know very well from previous years. So we've demonstrated it eventually.